I would like to present my solution for problem number 3. So what I saw is that diameter is NL, so this is 10 to 8. I know that this angle is 90 degrees. So immediately when I see a segment that I can compute, I better mark it in the picture. So I can compute what's KL. So KL by the Pythagorean theorem is what? 20 squared minus KL squared is 20 squared minus 18 squared. So KL becomes square root of what?
2 times 38.
Times 38, square root of 76.
Which is 2 times square root of 18.
Which is 2 times square root of 18. Yeah. So I can find KL. Now what I'm looking for actually ML, right? I know this 2 square root of 19, and I know this triangle KPL.
Yeah. Inside the circle, there are lots of similarities, right?
Yes. So I know, for example, these two angles are equal because they have the same, are based on the same arc, ML. In the same way, these two angles are equal. So this triangle is similar to this triangle, and I know all the information about KPL. So what do I have? NP over KP is equal to MN over KL. So NP is equal to 12, KP is equal to 9, this is given, MN over 2 square root of 19, right? So MN is equal to 440
over 9, so it's 8 over 2 times 2 square root of 19.
Looks pretty nasty.
Yeah.
Yeah, that's a nasty answer.
If you try to find the mistake, I don't think there is a mistake in my computation.
I don't see any mistake, but I got a different answer actually.
So why don't you try?
Okay, so I mean, I did it differently. So, well, I mean, I also used a different pair of similar triangles.
Right.
So I saw that this angle here is equal to this angle because they both have arc KL, and then this angle is equal to this angle for the same reason.
Good.
So that means that if we look at this triangle and this triangle, they're similar. So the ratio will be, if we try to find LM,
The ratio is 9 to 8, right?
Yeah.
Because KP to PL.
KP to PL is equal to KN over LM. So if you plug in the numbers, KP is 9, PL is 8, KN is 18, and LM is, this is a much nicer ratio. It's clear that LM is 16, right? And then in this triangle now,
It's also a right triangle.
because of the diameter. And then this is 20, this is 16.
And it's
And
3,
it
4, 5.
works out much nicely. It's a 3, 4, 5 triangle. So now I'm getting that MN is 12 from this 3, 4, 5 triangle, which is definitely not the same as 8 times the square root of 19 over 3.
If you go to the math connection of that year, you got a point, he doesn't. Because they think this is the answer. That's the official answer, right? So what really went wrong? Clearly we present 2 correct solutions, right? So we know problem is wrong, right? In what way this is wrong?
So I just feel like I think there are just way too many conditions in this problem. So first of all, we have NL be the diameter, which is already a pretty strong condition, and then we have a clearly defined triangle NPK, which has 12 sides, 12, 9, 18. So it's like a 3, 4, 6 ratio, and we don't clear that this cannot be a acute triangle, so I have to redraw the diagram. So I'll erase this one, I think. Sorry, bro. Okay, so we draw a 3, 4, 6 triangle. So we have 4, something like 3 like this, 6 like this, and then we need to have a extend this by n8 to point L. Let's label the length first.
You want to say NPK is defined because it's 18, 9, and 12?
Yeah, because by SS is congruency, this triangle, there's only one with just this triangle.
And then the KPL is also defined, right?
KPL is already defined because this angle is fixed, so this angle is fixed. Therefore this triangle is also fixed.
Yeah. So now the trouble is NKL is actually not 90 degrees.
Yes, this is this is evident from the two different answers.
Right? So there's another way of seeing this, why this thing doesn't work out well is, I'd rather go with the diagram he has, use the circle. I have 10, 2, and 8. So if I erase this, now I define K as they define. So I know 10, 2, and 8, I know this is 18 on the circle, right? So that means there's actually only one place. Okay, make this 18.
Yes.
But then you are not guaranteed that this side is what? Is 9 anymore. Because this is already a fixed number. Right? And our students actually can compute this number because of what? We should be able to compute this altitude, right? Right? So why don't you guys try it at home? Compute this altitude. And if you know this altitude, and you also know this length, based on this altitude, you should know this length. And then when you have this length is fixed, and subtract 2, so you know this length. So as soon as you know these two lengths, you should be able to compute this. And you can see that it's not 9.